This is a lesson on finding the equations of trig graphs, an extension, a continuation of what we have been doing the last couple. And I'm going to go through two examples that involve all the transformations we have looked at so far. So these would be considered the most complex of the batch. So to begin with, we want to find an equation for the graph below in the form y is equal to a cos b theta minus c plus d. So in other words, we want to express this one as a cosine curve. And the method is the same as it has always been for these type of problems. We need to find the four parameters a, b, c, and d. And I would also remind you that it could be a cosine curve or a sine curve. Remember, the choice is yours based on what you want to give or what you want to call the horizontal translation or phase shift. So let's begin with this. I always recommend starting by going after the d value, that is the vertical translation. And I encourage you not to make this more complicated than it has to be. The d value is simply the midpoint of the wave. Now, you don't have to draw the entire thing, but there is a dotted line right down the middle which represents the center of the curve halfway between the min and the max. And you can often recognize it. Like when I draw this like this, I can tell you that d is equal to 6. I just found by inspection the halfway point. You can also use that formula. Now, this is not provided for you on any formula sheet or anything, but it is really just the midpoint formula. So we take the min value plus the max value, and we divide it all by 2. So d is equal to 0, the minimum value, and the graph maybe isn't perfectly clear on this, but the upper maximum value is 12, and then divide by 2. So d is equal to 6. So we'll stick with that for a bit. Now, once you have the d value worked out, you do have a choice. You can go after the other ones, but the easiest at this point will probably be the a value. So I'm going to do that now. This is a new screen. But the a, we can either go after it by inspection again, considering there's the midpoint. Do not make it more complicated than it really is. This would represent your amplitude. Now, it's true that the a value could be either positive or negative, depending on your choice. But once you get the amplitude, you can go either way. So really, when I ask for the a value, I'm really trying to find the amplitude. And by inspection, you might note, if you take the max value minus the midpoint, you're also going to get 6. But you can also get the a value, the amplitude, by going max minus min and then dividing this by 2. So that would be the maximum value of 12 minus the minimum value of 0 again, and dividing by 2. So we do get amplitude, or a value, is equal to 6, which is equal in this case to the d value, but of course it doesn't have to be that way. So we have our d, we have our a. Now we have to go after the horizontal measures, that is b and d. So I'll do the b first. And the b is all based on getting the period. So we need to find the period. And where possible, and it isn't always possible, you go crest to crest. Now, you could also go y-intercept to y-intercept, or what the y-intercept is, and find the corresponding point on the other graph, like this. It really doesn't matter, but the period would represent one full cycle. And often, if not always, the period will be easiest found by crest to crest. So in order to get the period, I take that 7 pi over 3, the one crest, minus the other crest, which is at pi over 3. And by subtracting these two, I get 6 pi over 3. And 6 pi over 3, if you go further with it, would simplify down to 2 pi. Now that's interesting for a number of reasons. Well, at least mildly interesting for one reason. The period of a cosine or a sine wave is 2 pi normally. That's what we would expect. So in other words, with 2 pi, if you think of it, there is no horizontal stretch factor. And I'll work that out still using the formula, but I'm expecting the b value to be 1 because the b value is always equal to 2 pi divided by the period. So b is equal to 2 pi divided by 2 pi, and yes, there we have it. b is in fact equal to 1. So we don't really even need to include that in our final statement. What's left is the c value, the phase shift, and this can be a problem. So for the c value, we have decided to call this one a cosine curve. And if you recall from the earlier lesson, it's all about finding the starting point. And a cosine curve should begin right at the crest. That is to say, the crest should be right there. That's where we would expect it. And instead it's been moved pi over 3 over. And so you don't use much math on it. You just take it by the graph, by inspection. C is equal to pi over 3. So we have a horizontal translation of pi over 3 to the right. And then you just put the whole thing together. Excuse me. So when we get all this, then we can now say that our A is equal to 6. We knew that. Our D value was equal to 6. The B value was 1. And the C was equal to pi over 3. And we were calling this a cosine curve. So therefore, down at the bottom, I'll write that. Y is equal to 6 cosine. I'm not going to bother with the B value. I'll just go theta minus pi over 3 and then plus D. So that's how these work. dA, BC. I'm going to go back to this graph, and this time, however, I'm going to be getting an equation where A is less than 0. That means negative. So in other words, where there's been this reflection over the x-axis. And AB and D will remain the same. So all we have to do is find C. So bring up a screen where I can see all this. We have a choice because a cosine curve should begin at the trough. So we could either go to the left or we could go to the right. It doesn't really matter. So negative 2 pi over 3 or 4 pi over 3. Both would be the same. But if this was a cosine curve that had not been translated, this trough should be at the bottom. So we could write it therefore as y is equal to 6 cosine, negative 6 cosine theta minus 4 pi over 3. So that's the one, if we moved it to the right, plus 6. Or, if you went the other direction, y is equal to negative 6 cosine theta plus 2 pi over 3 plus 6. either one is correct. You just have to recognize where the starting point is, and the question you're asking yourself is, how far has that non-translated graph been moved to be where it is currently? And in both of these cases, the trough should have been on the y-axis. Now this next one, we did find 2 equations of the previous. This one requires us to find 3 equations. So it's not that big of a departure. And I'm going to do it exactly the same way as I did previously. I'm going to get my d value, my a value, and my b value. And I'm making the choice that I'm going to write this one in as a cosine function to start with. You don't even have to make that decision, because in fact the only thing that changes from one to the other is the c. And as is the custom with these, I will find the d value first. And if you possibly can, find the d value by inspection, because I can tell right now that the d value, if you consider we're going up to 5, well, okay, and that's also may not be perfectly clear off the graph, but it is halfway between 4 and 5. It is 5. And anything on exams, of course, will be really clear. The scale is a little tougher to work through, of course. But the d value is, in fact, going to be halfway between. So if you draw this one nicely, and actually I didn't do that good of a job, you can get it right away. And I will make sure that I get it right by using the formula, though. So min plus max divided by 2, just in case there's any doubt. So d is equal to, the minimum value is actually equal to -1. So -1 plus the maximum value is 5 divided by 2. So interestingly, that would be -4 divided by 2. D +4 divided by 2, excuse me, d is equal to 2. A little mix up on that one. So I could tell I didn't really draw it perfectly. It should have been better down there. And that, of course, is the real problem when you are trying to eyeball these ones. So d is equal to 2. Keep going, and we find our a value. So here is the midpoint, and you should be able to find out what the a value is based on the graph itself. Really, just if you're going from 5 to 2, it will be equal to 3. But for those of you who prefer to use the formula for everything, as long as you remember it, you're fine. The amplitude would be the max minus the min divided by 2. So the amplitude is equal to, the maximum value is 5 minus the minimum value, which is -1. So 5 minus -1 divided by 2. So therefore the amplitude is equal to 5 plus 1 is 6 divided by 2. So the a value is equal to 3. And keeping in mind that it is the amplitude that I've got, not the a value, we could write this as a negative graph, in which case a would be negative, but no big deal. So we're getting close. Now the b value, once again, I want to find the period, and to me this is a little bit hard to see where it's going to be. Like, you might be able to eyeball your way through this one. The period, if you take the y-intercept to be about right there, and it does appear that that cycles in pi over 3 rads. So by inspection, I would say, if I had no opportunity to work this one out, I would say that the period is pi over 3. However, I am going to work it out anyways. And the period, if you go crest to crest, say from this point to this point, we can do it mathematically. And we don't require a lot of eyeballing, because the one crest is 7 pi over 18, and then the other one is pi over 18, so that will give us 6 pi over 18. And if you simplify that, you'll get pi over 3. Of course, that's not our answer yet. But if we take the b value and remember that b is equal to 2 pi divided by the period, we should be able to get that. B, therefore, is equal to 2 pi divided by pi over 3. Now, I'm not going to do the full math on that because we've seen enough of these lately. But 2 pi times 3 over pi would give you a b value of 6. So we're getting very close. We have our A, our B, and our D, and those do not change. So we, at this stage, just have to find out the correct C values. Now, if we're going to call this one a cosine curve, we look for the starting point. So I look for the crest. And by inspection, C is equal to pi over 18. You could also go all the way to 7 pi over 18 if you wanted. So if we take a look at all the information we have y is equal to, the A value was 3. This is a cosine function. And then the B value was 6, so it's been compressed horizontally by a factor of 1 over 6. And then theta minus pi over 18. And then I'll close both brackets, and then our D value is plus 2. And we have the first equation. I'll bring up a new screen, and then we can take a look at another one. This time, I'm going to write it with A is less than 0. So we need to find a starting point. And just to keep things interesting, I'm going to take this trough over to the right, or excuse me, to the left. We could go to 2 pi over 9 as well. But if we do this, we get C, the horizontal translation. If you wrote it with a negative, it's negative pi over 9. But remember that really, when you're writing the equation out, all you're doing is reversing the sign for it. Just take that back for a sec. So this becomes y is equal to, with the negative A value, because it is starting at the trough, it becomes negative, the A value was 3, so negative 3 cosine, and big old bracket, and the B value we have to be 6, and then theta plus pi over 9. Close that little bracket, close the big one, and then plus 2 for our vertical translation. Now the difficult thing will now be to get the next one. We have to get a sine wave out of this. Now I suppose some of you would be arguing, well, I'll use another negative cos one, this time translating it 2 pi over 9. And you'd be correct. But just to make things more complicated, I'm going to go after a sine wave. And this one will be complicated because there's no real obvious starting point on it. You see, a sine wave should be, if you think back to the lesson yesterday, should be starting somewhere like there or there. And those ones don't line up that nicely on the scale. So this is going to require a little bit of work. And the key to doing this is to find the quarter. You see, the period is equal to pi over 3. And if we were to find the quarter, we could find all these extra starting points. So if you take that pi over 3, excuse me, times 1 over 4, you will then get pi over 12. And that represents the quarter. And you might be thinking, well, why? Why do I care about that? The reason you care about it is because this graph will always break into those 4 equal sections. I didn't do a very good job of drawing it, but more like this. And those 4 equal sections will enable us to go from a crest to another starting point. And if we want to say, for example, find this point, this would be a start point for a sine wave. We simply have to find out where that's located. And because we know that the crest is pi over 18, we just have to go back pi over 12, because each one of those sections is pi over 12. So pi over 12 this way, pi over 12 this way, pi over 12 this way, and so on like that. So if you wanted to get a negative sine wave, you could do that too. But I'm going to get the one to the left. So all I need to do is take that pi over 18, which is the crest, and by subtracting pi over 12, it will take me to that starting point. And you get a common denominator of 36. So this becomes 2 pi over 36. So all I'm doing is I multiply top and bottom by 2, and I multiply top and bottom by 3, and I get this. So 2 pi minus 3 pi is negative pi over 36. So that tells me that that starting point there is actually negative pi over 36. So we're all there. That's our horizontal translation if we want to write this as a sine curve. So we can take the whole thing together. Y is equal to, it's a sine wave, but I'll go A is 3 sine, B is 6, and I'll write this now as theta plus pi over 36. Close, close, and then plus 2. These are considered difficult questions. So that's it for me. Thank you for your time.